In this lesson, we're going to look at how to multiply fractions together. Now, the rule for multiplying fractions is that we multiply the numerators with each other and the denominators with each other. So if I look at this first example, where I have 3 over 4 multiplied by 5 over 7, I'm going to multiply the two numerators together, and I'm going to multiply the two denominators together. So 3 times 5, that's going to be 15, and 4 times 7 is going to be 28. And then I look to see, is there a number that I can divide each the numerator and denominator by to simplify? And in this case, there isn't, so this is done. Looking at another example of 3 over 4 multiplied by 8/9. So again, I'm going to multiply the numerators with each other. So 3 times 8 is going to be 24. And then multiplying the denominators together, 4 times 9 is 36. Now, I can see that in this result, these are both even numbers. So I can divide each of those by 2 to start to simplify. 24 divided by 2 is going to be 12. 36 divided by 2 is going to be 18. But these numbers are still divisible by 2 because they're both even. So I can divide by 2 again. And then I get 12 divided by 2 is 6. 18 divided by 2 is 9. And if I look at those numbers right there, they're still each divisible by 3. And so I can do this one more time to simplify the fractions. I'm going to divide each of those by 3. And I get my final answer of 2 over 3. Now that is a long process. What if these numbers are even larger? I don't want to continuously keep dividing by small numbers over and over and over again. So I do want to show you another way that you can try to simplify before you even multiply. So looking at the same example that we had, I'm now, instead of multiplying them right away, I'm going to factor each of the numbers that can be factored. And so I'm looking for numbers that work together. And so if I look at 8, I can write 8 as 4 times 2. And the reason why I chose the 4 is because there's a 4 in the denominator as well. And then with 9, I can write 9 as 3 times 3. And now, just like I used to do with simplifying, I can look for a number in the numerator and denominator that will divide to 1. And so I can see that this 3 divides by this 3 to give me a 1. And then this 4 divides with this 4 to give me a 1. Now, if I look and multiply these two fractions together, I get the 1 that's left over from here multiplied by this 1 multiplied by 2 is 2 over 1 times 3 is 3. So you can see that I get to my answer a lot quicker than, multiplying first and then simplifying. So let's look at another example with some larger numbers. And I'm going to do this example the two different ways that I just showed you. So again, multiplying numerators with numerators, right? 12 times 18, that's going to give me 216. And then if I multiply the denominators together, 27 times 36 is going to be 972. Now, instead of me looking for, the small numbers that I know are divisible, I'm going to, try to speed up this process. And I can see that both of the sum of the numerator and the sum of the denominator's digits, they both add to 9. So therefore, right off the get-go, I know that these are divisible by 9. And then if I do the 216 divided by 9, I'm going to be left with 24. And then if I do the 972 divided by 9, I'm going to be left with 108. Now, I know, just because I made up this problem, that, these both numbers are divisible by 12. So I'm going to divide by 12 again here. And then I'm going to get my final result, which is going to be 2. And then 108 divided by 12 is going to be 9. 2 and 9, they don't have any factors that are common, so this is in simplified form. The reason why I went through this one a little faster is because it really is more beneficial to simplify before you multiply. And again, you're trying to write these numbers as factors that have common numbers in the numerator and denominator. So if I look at the 12 and the 36, hey, they both have a 12 in them. So I could write 12 as, just keep it as 12. And I can write 36 as 12 times 3. Then with 18 and 27, I know that they're each divisible by 9. So I can write 18 as 9 times 2. And I can write 27 as 9 times 3. Now that it's fully factored, I can start doing my divisions and making 1. So I know that 12 will divide by 12, leaving a 1. And 9 will divide into that 9, leaving a 1. Now I can multiply. So this is going to be this 1 multiplied by 1 multiplied by 2 is 2. And in the denominator, 1 times 3 times 1 times 3 is 9. And there we have it, the final result. Now, sometimes, maybe you don't factor, into the biggest possible numbers that you can. That's okay, because maybe there's a chance where, this number comes out to be 6 over 27, right? And when you continually divide it to simplify, you would still be able to arrive at the fraction that is the final answer in simplified form.